Okay, welcome everyone to this week's OMR Architecture Meeting. Today we have a couple of topics. The first is a talk from Batir from the University of Alberta, who will provide some results from the extensibility analysis that they did on the OMR compiler. So I'll turn it over to Batir to take you through that.
Thank you, Daryl. I'm just going to share my slides. Can you see them?
Yes.
All right, perfect. All right. Hi, everyone. My name is Batir, and I'm a master's student at the University of Alberta Summer Lab. Today, we are going to present our collaboration work on the variability implementation challenges in Eclipse OMR. As you know, Eclipse OMR is a set of reusable C++ components for building language runtimes. It has components such as a JIT compiler and garbage collector. For example, we could build our own virtual machine for Python or Java or our own programming language. Since OMR supports many different languages and architectures, OMR has a mechanism to manage its variability. As you probably already know, it supports architectures such as x86, Power, ARM, and is also being used for compiling languages such as Java and Python. In this talk, we'll focus only on the variability in the compiler component, as is the most largest and the most central component in Eclipse OMR. So Eclipse OMR variability mechanism is a variant of static polymorphism, so everything has to be resolved at compile time. To be able to do so, OMR uses a combination of extensible classes, C++ namespaces, and several other constructs. The reason behind such a complex mechanism is performance. Runtime performance is crucial when building virtual machines and just-in-time compilers. In order to be competitive, OMR developers are trying to optimize runtime performance as much as possible, and thus get rid of unnecessary runtime overhead, such as using virtual tables or this pointer in C++. However, the current mechanism has several challenges that impede simplicity and usability OMR and present challenges for both OMR developers and clients. Thus, our goal in this collaboration is to help OMR developers understand variability in their code and investigate variability implementation alternatives. In 2017-2018, at the beginning of our study, we thought static polymorphism was the root of all problems behind the variability implementation in OMR. We thought it was just too complex to understand for client developers and made it more difficult to maintain and further improve code to support more downstream projects that use OMR. Our first attempt to alleviate the challenges regarding the mechanism was to switch to dynamic polymorphism. We hoped that it would make it easier to manage variability in OMR, even at a small runtime cost. And previous researchers in the study wrote a few articles on the challenges with the current mechanism, as well as the transition to dynamic polymorphism. They developed OMR Statistics, a tool that would help OMR and client developers manage their variability, and made it easier to visualize and understand the extensible classes that they're using. They also refactor some of the extensible classes to use dynamic polymorphism constructs, such as virtual methods. However, there were still challenges, requirements, and constraints beyond static polymorphism, which dynamic polymorphism alone cannot address. We decided to take a step back to get a complete picture of all the challenges and constraints in OMR. From the complete picture, our latest focus on this work as researchers is to identify and design challenges posed by the current variability mechanism and explore any better design alternatives or tools and techniques that could help both OMR and client developers. Therefore, we proceeded with our goal in two big steps. First, we identify the requirements, and second, we explore existing solutions from the literature as well as industrial case studies. For the first step, to get a complete picture and understand what a better design alternative looks like, we interviewed 6 developers who contributed or either worked with OMR and whose experience ranged from junior up to senior level of 20 years of experience. We asked developers about challenges they faced when working with OMR and what they would like to see in a new design, and if there were any constraints that need to be taken into account. We then analyzed the results and came up with a list of requirements. Based on the continuous discussions with the team, we prioritize the requirements based on their level of importance. Based on the challenges as well as constraints, we came up with a set of 11 requirements for a new design. After discussions with the team, we prioritized this, and you can see six of them here on the slides. The relevance of the requirements was determined based on the discussions with the team, as well as their relevance to the variability mechanism itself, rather than due to inherent design or process problem. Examples of these requirements are the priority on simplicity and usability of a new design, as well as some mechanism that will provide the ability to extend C++ enumerations and unions. For example, let's take a deeper look at one of the requirements, namely the C++ Enum extensibility problem. So a virtual machine takes a source code written in some language and executes it. To be able to reason what to do at a certain point of a program lifetime, a virtual machine uses its own set of opcodes. Each opcode specifies the instruction to perform. For example, iconst loads an integer constant, while lconst loads a 64-bit or long integer constant. And each opcode has a list of properties such as name, token, and other properties used by the virtual machine. For example, the return type or the argument types. The files that you see here are named differently, but for the sake of brevity, we decided to name them opcodes.hpp, which contain enum values, opcode properties.hpp, which contain array-like entries with all opcode properties, and opcode enum.hpp, where opcode enum values are included. So all these files refer to the same set of opcodes. Each of these files provide a certain piece of information for each of the corresponding opcode. The first element in opcodes.hpp corresponds to the first array inside the opcode properties.hpp, and the second element corresponds to the second entry. In the compiler component, there are many spread out header files like that. So it's important that if, for example, the first opcode in opcodes.hpp is iconst, then the first entry in opcode properties.hpp containing an array of properties should correspond exactly to the first opcode in opcodes.hpp. The same logic stands for the rest of opcodes. The problem here is that if you accidentally swap iconst and lconst on opcodes.hpp, the long constant opcode will now have the property that integer constant should have had. So this, in fact, may introduce bugs that may be very hard to debug because the order of these opcodes in these files are not tracked automatically. So either client developers or IBM developers or OMR developers, will need to manually track the order in all the different files with all these opcodes. So if you did everything correctly, this is an equivalent of what you would get after preprocessing all macros. And this is a comment from one of these files in OMR compiler component. In the previous example, we just saw 2 of them, but in reality, there are more than 10 of these. So if you accidentally forget to adjust just one of these files, we may introduce bugs that may only pop up at runtime. Therefore, we need a centralized way of control of these opcodes and their corresponding properties. And the problem here is that C++, there is no natural way of extending C++ unions or enums, the same way you would extend classes or structs. So this leads to extending opcodes being more confusing and error-prone. So as a step 2, after the requirements were gathered, we first looked into the literature of existing mechanisms. Since there is a variety of mechanisms for variability management, we focus on the 3 most relevant to OMR in this talk. In general, the mechanisms vary from being fine-grained to coarse-grained. In other words, a fine-grained mechanism is at the level of statements, for example, if conditions. And then you have methods and functions, and more coarse-grained mechanisms such as classes and even coarser components and modules. In addition, the mechanisms can be either applied at compile time, load time, or runtime. First, the parameters are a fine-grained way of variability management. So it's essentially if statements, very similar to feature flags. In this example, we have a feature of color printing of a graph, which can be controlled using the conf class on the top figure. Parameters are quite easy to understand and use, and most programming languages support these because most programming languages have if statements. On the other hand, though, they create code bloat and add runtime overhead because now you should deploy all of these statements to production, and all of these statements should be evaluated at runtime. In case of OMR, parameters could actually contribute to a simpler and more usable design. They're already being used to manage compiler options, for example. However, they cannot solve all the requirements. First, they're useless in terms of the Enum extension problem, and there's really no way that if statements could help resolve the need for varying constructors between architectures. Next in our list are patterns. Patterns are a set of reusable and general solutions to common problems, to commonly reoccurring problems in software design. You probably all heard about factory, singleton, decorator, and strategy patterns. Since the solutions are general enough to be coded in most OOP languages, there are discipline guidelines of how to implement them. However, before implementing a certain pattern, we should know all the extension points, or the points through which you can supply additional functionality in your program. For example, like providing callbacks in JavaScript functions or jQuery plugins. And if we miss something in our way, the pattern may later turn out completely useless and probably even harmful. And some of the patterns also add boilerplate code, as well as make code more complex. So given the disciplined nature of design patterns, it could be somewhat useful to apply this in OMR to bring in simplicity and usability. It could actually make it easier for developers, both OMR and client developers, to communicate with each other and better understand the variability mechanism, because the patterns are well known in the developer community. However, OMR developers are not going to stop working on the features and instead turn into large-scale refactoring to some design pattern. Development has to continue, and refactoring a large code base into a certain pattern is merely infeasible due to time and resource constraints. And like the parameters, design patterns are not helpful in solving all the requirements, one of them being the Enum extensibility issue. Last but not the least, we have feature-oriented programming. It's a mechanism that relies directly on the notion of features. The core idea is to decompose your software into features it provides, and ideally you would have a component or a module per feature, so that you make sure that you ensure the separation of concerns. You can see on the screen the diagram that's called the feature model. The model depicts all features of a system and the relationship between different features. For example, the filled circle near the base rectangle on the left represents a mandatory feature, so it doesn't matter which end product you deploy, the base feature is going to be always there. But the circles that are not filled represent optional features. Therefore, you could have a weighted graph or color graph, or both, weighted and color graph. Similarly, in OMR, you could mandate certain compilation processes or algorithms to run in optimization or backend phase, as well as provide some optional ones if they apply in client's case. The following figure shows that we can create 4 different end products, namely the basic graph, weighted graph, color graph, and both weighted and color graph. Each of these gray boxes represents a feature module. To reuse classes across feature modules, we need a way to override certain methods. This is a snippet written in Jack language. Jack is simply an extension of Java language for feature-oriented programming. Here, class refinement is used instead of subclassing. The refinement is a form of mixin-based inheritance, in which subclasses, or mixins, are abstract in the sense that they can be applied to different concrete superclasses. You can also think of mixin-based inheritance as the static counterpart to the decorator pattern. Mixins are also somewhat useful to traits in the Rust programming language. And in this example, we're refining class graph to add the notion of edge weights, since our original graph doesn't understand the notion of weights. And in the weighted layer, we're adding the notion of edge weights to make the graph weighted. With feature-oriented programming, developers really get a good feature traceability, because ideally, since you have each feature per module, it's easy to track where each feature is located. However, feature-oriented programming requires additional tool support. C++ doesn't provide any specific constructs for feature-oriented programming, and the paradigm has only been used so far in academia. In OMR, feature-oriented programming the paradigm could actually help improve simplicity and usability of the project. It would be much easier to track where each feature is located and how to combine these features into the end products. However, transitioning to the paradigm requires a complete rehaul of the system, which is infeasible due to time constraints. It doesn't guarantee that it will solve all other requirements as well, such as the Enum extensions or the variant constructors. We also looked into existing industrial case studies of highly configurable software when surveying the literature. Most of the industrial case studies focus on extracting a software product line from already existing set of end products. It means that a given set of end products, product A, B, C, the researchers wanted to extract the commonality between these products into reusable assets so that they can potentially tailor these reusable assets as well as the products to more markets. For example, ML PolyR is a family of compilers for ML PolyR language. Their family of products is different from OMR because they focus only on a single language, namely the ML PolyR, while OMR strives to support many different source languages. Similarly, Polyglot is an extensible front-end compiler, which only compiles Java to Java bytecode, which is again different from OMR. On the other hand, OMR is already a highly configurable system. Its software assets are the C++ components like just-in-time compiler, garbage collector, and a pthread-like library. Its product derivation process is realized through the use of CMake, the build system, and the C preprocessor. And in the end, developers are able to derive end products such as OpenJ9 JVM, a virtual machine for Ruby, Smalltalk, and a few other languages. So industrial case studies didn't help much because the projects they have are much less in complexity. They're much less complex, and they provide much fewer features than OMR. Based on our observation, so as we saw before, off-the-shelf mechanisms are not applicable in our case due to project's complexity. Re-engineering entire projects to a software product line or any other component-based mechanism such as feature-oriented programming requires deep expertise of the code base and direct involvement of the team members. And this is not feasible due to time constraints. And definitely there is no one-for-all solution that could help solve all of the design challenges at once. So instead of trying to satisfy everything, so all the requirements at the same time with a single mechanism, we divide and conquer. We pragmatically examine one problem at a time and propose a solution to it. Using our approach, we implement a solution to the C++ Enum extensibility issue. We, as researchers, chose this particular requirement because it's concrete enough that it doesn't require much involvement from the team members. And if solved, would have a positive impact on improving code quality and making the process of extending opcodes in OMR much easier and simpler. Now let's take a look at what we can do about the Enum extensibility problem. After looking at the literature as well as open source software, we can go into two directions. The first one relies on an external domain-specific language, and the second one uses the C preprocessor and its macros. The first direction takes an inspiration from TableGen, an LLVM tool for recording architecture-specific information. TableGen provides a variety of constructs, such as definitions and classes. The TT files contain the information in a particular DSL, namely the TableGen, which are then transformed into .inc files, or the C++ include files. The include files are later generated. These include files are generated by the tool, which are consumed by the classes in the backend in an LLVM. For example, the x86 backend defines a register class named gr32 that holds all of its 32-bit registers. So if certain instruction needs to use one of these registers, it can reference this particular definition, or when the operation involves some of these registers. So TableGen doesn't have to be directly used in OMR. It just gives us sort of an inspiration or a concept of what a domain-specific language we could devise on our own. For example, in our own DSL, we could add additional constructs for extensibility so that we can reuse some of the opcode information. In OMR, we could have also developed our own DSL, time-consuming. It doesn't work well because it doesn't really help solve the extensibility issue in a sense that downstream projects or the clients will still have difficulties maintaining the opcode files. In addition, both OMR and client developers will have to learn the new DSL. Alternatively, within the same direction, instead of devising a new DSL, we could use a set of JSON files, as well as some Python script that would consume the information about opcodes from the JSON schema and output C++ for us. In that way, they could eliminate the need to manually change the opcode files. It's also easy to understand and use JSON file. It's pretty intuitive. However, OMR developers try to keep the system as minimal as possible in terms of its dependencies and do not want to include any unnecessary Python dependencies in the project. This approach would additionally force client developers to install Python on their computers, their platforms, as well as OMR developers who would need to install Python on the build servers for all the supported platforms. The second direction takes an inspiration from SpiderMonkey, a JavaScript engine developed by Mozilla. This solution is used in the engine that also contains a G compiler and has its own set of opcodes. It uses macros for keeping the opcodes information. In this example, we store the information such as the name and properties of opcodes in the form of a macro. In this code snippet, developers from Mozilla defined for each opcode macro, which has a parameter called macro. This parameter then gets invoked with all the information about opcodes. Let's see how we can use this for each opcode macro. Say for some file, you just want to get the names of all macros. You don't really care about the index or the second argument, representing some information about opcodes. So you define a getName macro in the bottom figure, which just returns a name and a comma, since we call the macro inside a list. As you define getName macro, you pass it as an argument to the for each opcode macro, which then invokes getName macro for all opcodes. So you are calling this method here, this macro here, and this is an equivalent of what you would get in the end. This is actually a result of preprocessing that macro, which simply returns names of opcodes along with commas. So there's really, as you can see here, this solution is definitely not the best solution, and there's really no silver bullet. As you can see, it takes a bit of effort to understand what's going on here. It also doesn't directly make C++ enums and unions extensible. In the end, though, we chose to implement this macro-based solution because it has been the preferred one by the OMR team due to its minimalism and simplicity, and it actually does solve the problem of making it easy to extend and track opcodes in different files. As of today, the implementation is complete, but has not been yet introduced into the master branch. We have opened the pull requests at the GitHub repository, at the OMR repository on GitHub, where we have incrementally published changes and communicated this with the OMR team. So in total, we introduced one central header file with 735 opcodes, each containing 14 properties. We replaced the alt content of 12 header files. Some of you may know that some of these files contain more than 10,000 lines of code with a single macro in each, not more than 50 lines of code each. While some of these requirements and challenges we discussed may be specific just to OMR, we think that experience that we acquired working with the variability in OMR could be very useful for other industrial case studies. First, when we started collaboration back in 2017, we focused solely on the idea of extensible classes. We explored the transition to dynamic polymorphism, but quickly realized that there are challenges and constraints that dynamic polymorphism cannot resolve. While we had regular discussions with the team, with our direct collaborators, we realized that a bigger conversation with the whole team is necessary to get the complete picture. Second, as researchers, we were inclined to think that latest and greatest would always be the welcome solution for the requirements. However, the interviews and discussions with the team revealed that there are constraints that can easily rule out such options. For example, the least common denominator of C++ version must be supported on all different platforms, meaning that OMR developers cannot really use all of the C++ 14 or C++ 17 features. That could actually help solve some of the requirements. Third, we realized that the complete rehaul of the system to use larger strategies such as feature-oriented programming requires direct involvement of the team members. The massive reengineering effort and process requires deep expertise of the code base, which a research team will not be able to have despite collaborating for a couple of years. That said, when it came to working on a specific reengineering effort, we were able to implement that while just needing code review from the team. Finally, we would like to thank Xiaoli Liang, Nazim Khoyan, and Daryl Meyer for their involvement in various stages of this work and for continuously giving valuable feedback. We would also like to thank everyone in the team who have helped us answering our questions and reviewing our pull requests. In summary, we presented the variability implementation mechanism in OMR and the reason behind using static polymorphism. We also talked about identifying, analyzing, and synthesizing requirements for a new design. After all requirements were identified, we looked deeper into one of them, namely the C++ Enum union extensibility issue. For finding solutions for the requirements, we explored solutions from existing literature. We presented several directions for solving one of such requirements, namely the C++ Enum issue. And we shared our experience as researchers that could be useful for other industrial case studies. Thank you. Okay.
Okay, thanks. Thanks, Batir. Are there any questions for Batir? I have one.
Yep.
So the approach for using like the table gen approach is useful for producing tables of data that can be specialized. And I think that when we had talked about this as a community before, that seemed to be one of the areas that we thought would be that we would support exploring. And I think that the work that you've done with the opcodes and things like that has sort of been in that vein. Do you have any thoughts on how that could possibly be applied to code as well? If there's any way that we could do that kind of specialization for code sequences, because a lot of the specialization, the extensions that actually happen are in the code. There's bits that are particular to a processor or particular to a project. Are there any thoughts on that?
So you're asking about how, for example, TableGen could potentially be applied in OMR in its case of, right?
Well, thinking specifically about not just data, but if there's ways that this could be applied to code as well.
To code.
Actual executable code. I'm going to specialize this method with components from, this for this architecture, for this project, that kind of thing. I mean, there's a number of challenges with that, but I'm just wondering if you've given that any thought.
For that particular issue, not really. Since we only focused on trying to sort of, even if we find some solution from the open source software, we try to see how it would particularly fit opcodes and their extensibility issue. But with regards to being able to use it specifically for code.
Daryl, can I just clarify? Do you mean generating code that would have equivalent of source code, or do you mean something at runtime like instrument?
Yeah.
Okay, so if it's the first,
so not just tabular data, not just data structures that you're producing. That's composed of architecture specialized stuff and project specific stuff, but actually doing the same thing for code.
I think it can work because most of actually the domain specific languages is for generating code. So you have a specification of some sort, and the language allows you to specify different parameters, different kind of options, and then you can generate things. So if you're saying that for a lot of the extensions, it's really more or less a template or it's a pattern that keeps recurring, but with different parameters. I think that can be a good candidate for a DSL where the clients just kind of write very clear, here are they use for these, and then that. I don't know if that was what you had in mind or if I misunderstood.
Yeah, that's what I was thinking I was thinking along those lines as well. I just wondering if you had given any additional thoughts to that. So,
so the that's this, but I think one of the worries there was traceability in terms of both like debugging if something goes wrong and kind of figuring out where that piece of code came from and kind of consistency. If it's all about like generated code that's not going to get touched, I think is okay because you could keep that traceability. The problem arises if somebody tries to actually change that generated code somehow, and then you need to reflect that back into the original specification.
Yeah, that's been the main criticism, if that's not the right word, of that approach, is that you need to be able to understand exactly what it is that you're debugging, and then making sure that any changes that you make get reflected in that. So, very cool.
Yeah.
Other questions for Batir?
So I have a question actually for the team. Like, do you think that like this the current extension of like the enums with the macros and so on, is this something you have a plan for integrating at one point? Because I think that was the preferred solution, and that's why we went for it.
I think so. I mean, I think he's got a pull request open. I think it's been under various stages of reviews. I think that just needs one final push to kind of get that in. But we did discuss this on a community call, a few months ago, and I think that's what sort of precipitated some of this work. So I think that there is support in the community for doing this. So it's just a matter of getting that in. So. Okay. Anything else for Batir? Not. Thank you very much, Batir, for presenting that.
Thank you.
Like I said, the community will certainly work on getting your pull request integrated into the, and hopefully that'll serve as a sort of a model for other kinds of data tables being refactored that way and integrated. So thank you for that contribution.
Thank you. Yep. And please let me know if there's any further feedback or if you have any issues like with the pull request. Yep.
Sure. Sure.
Right.
Okay. Thank you. So let's see. We have 40 minutes. So let's move on. Okay, so we're going. So because we have time, we only had one agenda item. I thought that we would continue the work that we've been doing to review some of the older issues that we have, so that we can make some progress on these. So I picked a bunch today that hopefully we can get through. So the first is 165. It was created in the very early days of the OMR project, even before the compiler component was open source. So just after the initial contribution. This is really just in my opinion at least, it seems to be just a request that that more documentation be contributed to the OMR project. There were a couple of questions in there about like where do we put it and that kind of thing, but really there has been not really any activity in there for almost 4 years now, and I'm thinking that this particular one, well, first of all, what is the purpose of this particular issue anymore, and secondly, I think that it could probably be closed. I'm not sure that it's the umbrella document for documentation. Does anybody have any opinions on that, or thinking that it should be kept open if there's a broader purpose here that that it's trying to serve.
I think this kind of falls into what we discussed last time about just writing Markdown documents. So I don't know, as far as I'm concerned, this is a solved problem. We can just close it off.
Yep, I'll agree with that. Okay, any other opinions on that? Okay. We'll do that. Okay. Okay, moving on to 2.14. So that is another old one where I think somebody got an initial look at the OMR project when it was first created, and they discovered that there wasn't really a lot of documentation on what platforms it was supported on. I think you can kind of derive that based on the builds that are happening, but even now, I don't think that we are fairly explicit about what platforms are supported. Yeah, so the work here might just be to add some documentation to the README, for example, that really just describes the supported platforms. And go from there. So I don't think it needs to be closed, but I think that the direction, it just needs to be clarified a bit what the next step here is. Any comments on that or thoughts?
I think this one should be placed on the backlog. And the reason is because of the next item you have there. So unless we explicitly state which platforms we support, we can't drop support for any of the processors that we claim support for. I guess this is kind of feeding into the next item. For example, Z9 is currently not supported on any shipping Linux distribution. So maintaining that code in our repository is probably not warranted. But I can't drop it unless we clearly state that which Linux kernel levels we support, etc.
Okay, so is that the main reason that that hasn't been closed off, was because we don't actually draw a line on the sand and say this is the minimum supported?
Yeah, one of the reasons.
Okay. Okay. The other thing that has come up as well, back to 2.14, is support for 32-bit platforms, and where we are with that. We don't I mean, there is some minimal testing that happens on x86, but I don't think any other testing happens on other platforms for 32-bit. The question is whether or not that's even a supported configuration. Which I think
this is one of those things again, like the distros drop 31-bit support on Linux.
Yeah. Okay, so we'll keep 2.14, and then for 6.6.7, the Z9, Z10, I think you had a comment in there about waiting for some feature to be tested. That was about 3 years ago. Other than the documentation aspect, is there something else that you need to happen for 6.6.7 to be?
Yeah, I'll take action on that one. I have a pretty good summary of why we should drop Z9 support specifically, but keep Z10.
Okay.
So I'll take that issue and I'll post an update.
Okay. Alrighty. Let's see. Next one I have on my list is 670, and I don't have that issue in front of me, but when I recall, this was someone from outside the usual project members that came along and discovered OMR and was asking about creating a DSL that would feed into something like JitBuilder. And I think they had some. The thinking behind that was that it's a bit easier to express some of the some higher level languages in that and getting it to integrate with OMR. I don't think he actually got a reply to his question. Around that time, he asked a whole bunch of questions, and this was just one of them. And I don't think we actually replied on this one. My thinking on this, and I was kind of hoping that Mark would be able to answer something here, but in terms of dovetailing with JitBuilder 2.0, there might be something there that could address this. The other thing that I was thinking as well for ideas like this, and this I don't think this is the only one. I don't think this is the only issue that we have. But what I was thinking that we could maybe do is to actually create a new kind of label, let's say research or something like that, for projects that aren't necessarily a bad idea, but are more in the sort of the research domain or the exploratory domain than an actual thing that we would build into the product. It'd be useful to find those sorts of issues that that would be research projects for someone to investigate. So for this particular one, I was going to propose not closing it, but actually moving it into sort of a research category that we don't necessarily forget about, and that somebody could make progress on if they wish in the future.
I think we had those Google Summer of Code labels. Those fit under research?
I was thinking about that too, but those Google Summer of Code ones aren't necessarily research. They're more really just, they should really just be writing code, right? And getting something out. This might require a bit more design and a little bit more research in order to get it done. So we could potentially apply a research tag to those Google Summer of Code labels as well, but I wouldn't necessarily want to label this one as a Google Summer of Code item, just because I don't think it is. It's just there's too much thinking that would have to go into it up front for that to happen. Any other thoughts on 670 from anyone? It's awfully quiet today. Okay, so if there aren't, then I think that'll be the disposition for 670. On to 683. So this was another series of questions that was asked by the same person, which, if I recall what this one is about, he was asking about a whether or not we could support or in consuming multiple sources of IL into the compiler. And I believe Mark actually replied to this with some other questions, some clarifying questions that we needed answers to in order to better understand the situation and what the use case actually is. And I don't think that there's been any response to that. So I think for us to make any further progress in this, we'd need an answer. So I'm going to propose that we close this one just because it has gone on for about 3.5 years now without any activity. So
yeah, I think this one is a dead issue. I'm trying to sort of understand what his use case is, and maybe one interpretation is that he'd like to be able to have multiple compiler components linked into a single VM.
Mm-hmm.
Or it could be just one compiler component capable of consuming multiple yeah, you know, like formats. It's not entirely clear what he's asking for.
Yeah.
Yeah, the only thing I'd add to that is that we do have a pull request that's languishing from one of the CanOSP projects, which was the tree interpreter for the JIT, which we may still want to make sure we get around to merging at some point. I just wasn't qualified to do that because I was involved in its development, so I don't want to be doing a self-merge.
Okay, right. Yeah, we that was a relatively recent thing. So yeah, we don't want that one to fall off the radar for sure. So should make.
Yeah, I think the PR was opened over 2 months ago. So.
Okay. All right. So for the so the disposition for 683, I think we're just going to close it with a comment for more information in that. So. Okay. The next one is 1118, which was a question again from the community asking for a comparison between what we're offering in OMR versus what is available in truffle and graal. John Dumovich wrote up a very nice articulate answer to the question, and I think that there was some further discussion after that, which moved things forward as well. I believe the question has actually been answered. So in terms of what was originally requested, I think we've done that, so we can close it off. But I also think that perhaps the answer that was formulated as a result of the discussion that happened during this, it would be good to document that somewhere. It would seem like it would seem like a perfect FAQ kind of question, except we don't really have an FAQ, but or do we? I don't think we do. But it would seem like a perfect FAQ question. So having it live, for example, in a README file, for lack of a better place, or perhaps we should even start an FAQ.
Dare I say the word wiki?
It can be our one wiki article, yes. Yes, so I think the answer needs to have a home somewhere. Just need to find where that home actually is. I think at the very least, creating a document that lives in the documentation directory or in the README somewhere that describes the difference would be helpful. I thought we did start an FAQ at one point, though. I must be thinking of something else. Any thoughts on this one from anyone?
Well, I think we need to create somewhere where we can do those kinds of compare and contrast, because I mean, people are also going to ask about how OMR compares to LLVM or how OMR compares to some of the other frameworks that are out there. So having a place to articulate that is probably sensible, because it's kind of important for people who don't know what OMR is to be able to figure out what it is, right, relative to other things they understand.
Right.
Like certainly, I think we should probably also have one for LLVM, right? Like how is OMR different, the same?
Yeah, I've seen that question answered in the past, and if it's not part of one of the issues, it might be part of some other documentation that I have. I'll have to try to dig that up and maybe surface that as well, along with this truffle graal comparison.
I mean, one possibility could be that we could create it as a markdown document in the root of the docs folder, just kind of say something like, you know, a comparison to other compiler frameworks, and then reference it from the README or something like that, right? Like where you're saying, what is OMR? Mm-hmm. And then you can have a section there that says, if you're already a compiler / runtimes aficionado, look here for a comparison to other frameworks so you can understand the unique value proposition of OMR or something like that.
Mm. I'll go along with that. Any other thoughts on this? No. Okay. And then the last one that I had on my list for today was 1170. And that came from a question that somebody had asked about whether or not, if they use JitBuilder to produce, if they built a compiler using JitBuilder, would it be possible to actually produce output in an ELF format? So rather than a dynamic compiler, write it out to ELF, which can be linked. There was a fair bit of discussion that happened in this issue. A lot of back and forth between Mark and the person asking the question. In the end, however, since this question was asked, we have actually gone and implemented better support for generating ELF objects. There was an initial implementation done around the time of this question, which is usable, and then a couple of years back, Nazim came along and re-architected that a bit to make a more consistent implementation of it, and more usable implementation of it. So that's still there. We do have limitations, obviously, with our ELF support. We only do code, for example, at this point. We don't support data relocations or anything like that. But for the purposes of this question, I think I think we've answered it in the sense that we do want. Well, there is some support available for generating ELF. But I think the broader issue of more complete ELF support still needs to get done, and so perhaps that might be an issue unto itself, rather than tacking it onto this question. So the rounding out the support for ELF would be one of the ways to go. One of the things that we had talked about as well with when Azim was looking at LLJB was one other extension of that would be to actually have that go directly to an object file so that you can link it against other things and use it in other kinds of comparisons. So that could be a further extension of this work, should somebody want to do that. Any thoughts on this one? So I'm proposing closing it, basically, and then perhaps creating another issue that would track proper complete ELF support in a very top level issue. No details there, really. No. Okay, that's what I'll do then. Okay, that's all that I had on the agenda for today. A little bit quicker than I expected, but thanks, Batir, for taking us through the results of your research project. And I think we will adjourn if there's nothing else. Thanks, everyone, for joining.
Thanks, sir.
Thank you.